Hello everyone, good morning and welcome to WeAreDevelopers DevOps Best Practices. My name is Seyad and I will guide you throughout this event. Today it's all about DevOps. We will kick off the day with an interesting and insightful workshop about profiling and how you can improve the performance of your applications. Then we will have interesting talks about decoupling, about GitOps, about serverless, and we will also get insights into how DevOps actually works at Netflix. So very much looking forward to that. Thanks again for joining our event of today, and also a special thanks to Platform.sh, who are our partner of the day and who make this event possible. So thank you, Platform.sh. Before we start, a short reminder: if you are interested to learn about the latest updates and insights in developing JavaScript or with JavaScript, then please check out our JavaScript Congress, which is coming in November to you. Check the awesome speaker lineup. We have cool people like the inventor of Angular and some other core contributors to popular JS frameworks. Check it out and save your spot. As always, for today, please stay engaged with us. Use the chat that you see just beside the stream and also submit your questions to the speakers. They will be very happy to answer all your questions right after the respective session. And for that, we have also prepared a very short video, our code of conduct, which is very important, as you know. So with all of that said, I'm very happy to announce our first speaker, the host of our morning workshop session. He is a Blackfire DevRel engineer with more than 15 years of experience in development, and he is a true expert not only when it comes to DevOps, but also in PHP and Symfony. And he will let us know how to improve the performance of your applications through profiling. Please welcome Jérôme.
Thank you, Sid.
Hi, how are you doing?
Well, pretty good. Pretty good. It's a regular Tuesday, right? Tuesday morning.
Yeah.
Exciting, giving this workshop.
That's good to know. You're joining us from Lyon. How's the weather there?
Well, quite cloudy, a bit cold. But yeah, that's okay. Okay-ish.
Okay, but it's the perfect time to have this workshop, right?
Yeah, exactly.
Perfect. Maybe before we start, would you like to give us just a short introduction? So what can we expect, or what will the audience learn from you today?
Sure. So, as he had introduced me, I'm a developer advocate, DevRel engineer at Blackfire, which is part of Platform.sh. So, Blackfire is a full application code observability tool, which covers profiling that we will see this morning, to monitoring your application live, and also a testing platform. So usually when we talk about observability, it's all about performance, as you said, and these are the kind of tools that are very precious for DevOps and developers in general, in order to understand the behavior of their application. And when I say behavior, of course, performance is a big part of this behavior, but it's not exclusive. We will see that during the workshop, that we can go a bit further than just focusing on performance. and that it can also be used to find bugs, for instance, to find the origin of bugs in your application.
Okay.
So, yeah.
Cool. Yeah, sounds very interesting, and we are very much looking forward to that. So, Jérôme, the stage is yours.
Thank you. All right. So, as I said, it's all about application code observability. I will start with some slides, so just from some theory, and then after that, I will dive into our application and do some live coding. Why is it important? Well, especially if you're a DevOps, you might already know this, but web applications performance has direct consequences on a company's revenue, especially if your application is like an e-commerce website, because documented researches show that when your pages load in more than 3 seconds, and I mean in total, not only in server side, 53% of them abandon the site because it's considered as too slow. It's only 3 seconds that's ages for an end user, and it has a tendency to decrease. And also, we know that improving a page load time by like 100 milliseconds, for instance, can increase the conversion rates by up that of 7.1%. These are the results of studies from Akamai and by Google from DoubleClick. We also know that Amazon had this kind of research internally, and they have exactly the same results. That each time they increase the load time of by 100 milliseconds or more, they see their revenue growing because they sell more. Right. So what can we do about that as developers and DevOps? Well, first, if you don't have the right tools to understand what's going on, well, you cannot improve it. Well, this is one of our mottos at Blackfire, is that you cannot improve what you cannot measure. So it's really important to understand how your application behaves, and then in order to spot the issues from your code. And this is important to split apart the code and the application. The code is, you can consider it as the blueprints of your application, while the application itself is like the machine running. It's like imagine you're implementing a bicycle engine. You see with a assistance engine. While you're designing it, you're writing the blueprints. You're checking everything with the blueprints, maybe with static analysis tool. But while you built it, and you start to plug it to the bicycle, it's now a black box. And when it's running, you cannot actually see what's going on inside. For this, you will need to put some probes in there in order to understand what's going on, how the different components of your engine interact with each other. And this is exactly what profiling is about. Here, I won't talk about monitoring, but just a bit in the slides further, but to understand the difference. But this workshop is really more about profiling, so having a deep insight of your application. And having a profiler is like in this slide, putting your glasses on. You see, you put your bionic glasses on that get you the ability to see what is going on within this black box. Right. Why is it important, especially when it comes to development, staging, and production? Well, we probably all know that solving issues has a cost. And the later you fix an issue, a performance issue or a bug in production, for instance, the higher will be the cost to solve this. So the takeaway here is to solve this, to identify and solve these issues, especially performance issues, very early in the process, because it costs a lot less money. And well, just a small word here about Blackfire. Blackfire has this very special feature, which is very important, is that it's production ready. It can cover all the stages of your development process, from development to testing and staging, and then to production. In development, you can debug, you can improve, you can validate and stuff. In the staging part, Blackfire can be used for testing, automated testing and validation. You can write scenarios with several performance tests in there. So while you're testing and deploying in staging, and then once it's in production, you can monitor the production. So this is the monitoring part, and also identify issues and understand why there are these issues. Especially, this kind of issues that only pops up in production that you cannot reproduce in development, for instance. I know this happens to all of us. So, and this a profiler helps you identify this if you can use it in production. And this is a key differentiator between other tools, at least in PHP, because most of the profilers in PHP, like Xdebug or XHProf, cannot be used in production because they add way too much overhead. And some word about the overhead. When we're talking about the overhead, it's like, this time addition that is taken by a profiler or anything else. But here about the profiler, it's the time taken to measure things. And this is key here, to measure everything. And when you activate XHProf, for instance, it will be activated and remain activated for every request coming in to your web server and your application. And this can be a problem because this can be very heavy, especially in XHProf, and even more with Xdebug. I'm not saying that these tools are not suitable for these kind of things, but you need to know that to be aware of that kind of overhead and what would be the consequences. If you activate this in production, you will definitely get in trouble because your application will get slower and slower. Well, what's the difference with Blackfire? Well, Blackfire also has an overhead because it's inevitable. When you're measuring something, it's always taking time. But the main difference here is that Blackfire only works on demand. It means that when you have regular requests from your end users, the Blackfire extension, so this is what we call the probe, it's a PHP extension, it stays inert. It doesn't do anything, it doesn't do any measurement. It will only activate if you, as a DevOps, as a developer, authorized developer, ask for a profile, being with the browser extension that I will show or any other Blackfire client. And at that time, the PHP app will receive the profiling request with a specific signature and so on. Check if you're authorized to profile, because of course, if it's in production, you probably do not want everyone to be able to profile, right? So we have this authorization system. And if everything is okay, then the probe activates and measures everything. But it doesn't have any impact to the other request. So basically, the overhead will only be for you, not for the other end users. And this is really important here. Right. So now let's cover what kind of metrics collection levels we have, depending on the kind of tools we're using. So I briefly mentioned monitoring. So monitoring is all about getting information of when and where issues or performance issues are happening, right? When, meaning in a global timeline. Did it happen at 1:30 p.m., for instance? You can see here with this graph that something happened within the 96th percentile in your application, right? And the where a monitoring tool will give you this hint about which requests had these problems. So when and where is a first good step, first good hints to understand what's going on. But it's really getting only into the surface, because monitoring, when you're going to monitoring, you're kind of instrumenting each and every request that are coming in. So that you do not want this overhead I mentioned earlier, or very little. So traces, regular traces, are the one that's only measuring like the main wall time. Wall time is a fancy word for time, so it's in the monitoring and profiling role. So how long the request took to complete, right? Also same for the amount of memory and a few other things. So it's getting really on the surface, and is very cheap in terms of overhead. It's close to zero. We also have what we call extended traces. So this is what Blackfire covers as well. Extended traces usually are usually extracted from like 1% of your global traces. Only 1%, because we're getting a bit deeper. So of course the overhead will be a bit higher, like it will be around 8 to 10% approximately. So it's important to only have samples that would not have much impact on your servers. But here we only have you can only give answers to the when and the where, and profiling will get much deeper in the process in your application, and will give you the hints to understand the why this issue is happening. And this is getting possible because then we're measuring everything. In Blackfire is a deterministic profiler and tracing functions. So you will have these kind of guys, these nodes for each function to understand how your application is behaving and where are the bottlenecks. Right. So let's summarize a bit and close up this theory. Traces is like traffic at a city scale, right? Here we have Paris, the traffic around Paris. We have all those green lines, orange lines, and red lines that show the overall traffic. But you don't really know exactly what's going on. You only know that where it is happening, and you can also get back in time because this has some history as well. Extended traces will zoom in, right? We had this issue, some red line here in this neighborhood. And here extended traces can show me that, oh yeah, actually we have a closed road. So that can explain a bit more what is happening here, but we're still in the when and where. And a profile will give you like a Google Street View of your application, of what's happening. So here we have a picture showing that, yeah, the road is clearly closed. And we have a sign saying that, yeah, it's closed until September 23rd. And we have a road surface renewal with that budget. This is more or less, this metaphor shows you more or less what is happening with traces, extended traces, and profiling. Right. some other stuff. Blackfire also gives you actionable for performance insight, and I will get much deeper into that during the workshop, so no need to talk more about that. And that's pretty much it for this. This is the book written by Fabien Potencier about PHP code performance that you can find on Blackfire.io website. You can read it online for free. And if you go to in-person conferences and that we have a booth there, we usually have these kind of books to give away for free. Right. So let's dive into this. So I prepared a small application for you. It's a Symfony application, Symfony 5.3, using PHP 8, right? PHP 8.0. And everything has been set up. Just a word about Blackfire setup. We have two key components. The first one is, as I said, the probe, which is a PHP extension, which role is to gather all the measurements, right? The raw measurements when you do a profile. But it's not sending everything directly to Blackfire servers for visualization. For this, we have an intermediate component, which we call the agent. It's a daemon running in the background. And it just sits here and wait for data to process and aggregates everything and do a few things before sending them to Blackfire servers. This agent here is mainly here to avoid blocking issues, because if imagine that you don't have access to the internet. I mean, on a brief period of time, and you don't want your PHP processes to be blocked by this. So that's why we have this intermediate component that does all the hard work and sends everything over. Right. So about this application, this is a little story about that. Is a club in North America which are reporting sightings of the Bigfoot. The club is called Sasquatch Sightings. Right. So this application is made like a blog. It's really straightforward. Nothing really fancy here. So we have this list of reports which you can see as blog articles, and also details with the details of the report and different comments there from members of the club. Let's take like the third one, for instance. You can see that here each comment. Everyone is skeptic here. That should not be. But anyway, this is what we call the user activity text. So you get this label based on the number of comments you recently did. Right. So I've been reported that some of the pages on this website were slow. So I'm going to investigate a bit, and I'm not sure exactly where, because the reports were kind of fuzzy. So I have to find which pages are getting slow. I could use Blackfire monitoring for this, but just let's leave this aside for now. Okay, so let's start from this one. This is a sighting page, and I want to profile it. So for this, I'm going to use this wonderful browser extension. So this browser extension is basically a Blackfire client. I could also use a CLI command with a Blackfire CLI command, which is getting installed together along with the agent and everything. So I have this big red profile button. So let's just click on it. When I click here on this, it's getting 10 requests profiled. This is why you have this progress bar. Why are we getting 10 samples? It's basically to have a proper average, because as DevOps, you probably know this. Your infrastructure may have some hiccups. Sometimes it's a bit slower. While it should really not. But if you want to have a good overview of what's going on, usually you want to take several samples. So that's what it did. And once it's finished, we have this summary. So we know here we have different dimensions. And so here is the wall time. So the wall time is the time spent between the very beginning of the request to the very end. Like if you could do this with micro time in your front controllers, right? But this wall time is split into two flavors, which this one, the input output or I/O time, and the CPU time. So I/O is basically the time spent by PHP waiting for something else or something external to PHP to accomplish, like file system events or database interaction or network events or whatever. CPU time is the time spent by PHP actually computing something, right? So doing some calculations and creating objects and stuff like that. We also have the memory dimension, the network dimension. So here it's a peak memory. Here is the network consumed by the application. Here we can find external HTTP request. Well, here we have none. And the database interaction. So we can see that we have 42 requests, SQL requests, which might also be a problem. But let's see. We also have two different view types. The first one is the timeline, and the second one is the call graph. The timeline is the representation of your profile on a time base. So from the very beginning to the very end, we'll see how it looks like. And the call graph represents what I showed you before in the slides. Is a representation of the different functions interacting with each other. So let's first click on the timeline. All right, sorry about the latency. Screen sharing and stuff is always getting things slower. Right. I'm going to switch to the classic view. Yeah. Okay, so this is what the timeline is about. You see this on this time-based profile, where on the x-axis we have the time spent. So from 0 to 383 milliseconds, just like here it was said. And on the y-axis we have blocks. Blocks which represent function calls. They are stacked because you see in the first place we have the front controller, the index.php. This is a Symfony application, so it's calling the Symfony kernel, which itself curls the pre-boot and then the initialized container, etc., etc. And we can now see that we were calling our main controller show citing action. So that's interesting. Okay, so we know where we are in our code, basically, what the application is rendering. And one key here is that the length of each block is always proportional to time. So here, the main controller show citing is pretty long, right? And if we go deeper, we stumble upon this template, and this is the template that is actually getting things quite long, which takes the longer piece, the longer part. So it helps us identify what we might do and what problems might be, right? And we can, of course, zoom in, like here. And okay, it base.html.twig. Everything happens in the citing show that html.twig. So we can imagine that it's the main template rendering the article page. And this one calls doctrine, right, for database interaction. It's hydrating hydrating a lot. So we know that it happens here and happens there and there and there. Well, we might have found our first clue to why our application has been reported a bit slow. And by the way, almost 400 milliseconds is definitely slow actually compared to the standards that we chose to have. All right. We also have this blue graph in the background. You see this blue graph that is growing and growing. This one has a very high importance because it represents the peak memory envelope which is growing. So it's an always growing graph. It will never get down because we're talking about the peak memory, and the peak memory acts as an envelope, right? You put things in there, but it gets growing. But if you remove things in there, like simple memory usage, the peak memory envelope will keep the same shape. So it's really interesting to have a look at this graph because it can help you identify memory leaks from your PHP application. Like, for example, you forgot to release the memory within the entity manager from Doctrine. This happens to all of us, and so you will definitely be able to spot this, like bumps like you might have here. You see, we have this like this stair. Well, you will be able to visualize those in order to find issues. And of course, this blue graph is also correlated to the time here, the timeline that we have, and with the blocks, the function calls that are being represented. On the left hand, we also have the timeline metrics. So what is a metric? Basically, a metric is a collection of costs. So they're here to be able to identify featured metrics, like here, the one from Doctrine. And let's say that Doctrine.entities.hydrated metric is a collection of function calls that are being labeled as this Doctrine.entities.hydrated metric. This helps us identify things, important things in the timeline. So with this color code, and if I hover it, just have a look below in the middle, you can see that it's also hovering, highlighting the blocks, the corresponding blocks, right? So these are basically groups, collection of costs, and for each event, for each metric, we usually have all the dimensions. See here, doctrine.rm.find, or even here I hydrated. It's been counted 42 times, and we have all the dimensions values. So IO 1 milliseconds, network 0, memory 1.4 megabytes, CPU time 139 milliseconds, etc. So, whoops, my chair was getting me a trick. So this is basically what we can find in a timeline metric. Usually, it's a good idea to first have a look at the timeline, because as developers, it's not 100% of us, but usually we have this timeline representation in our mind. Think, okay, first everything is going through the front controller, then it goes there and there and there and there. So here we have a clear representation of what is happening to have a first sight. So usually easy, low-hanging fruits clearly appear in the timeline. Okay. Well, we found that we have this issue within citing show.html.twig. We'll have a look later. And if I click, by the way, here, I will have the whole call stack. All right. So now let's explore all the other dimensions, and especially the call graph. So let's click on the wall time view. Oh, right. So here we have a tree with different nodes. And starting with a main node here, right, which is represent the main PHP main entry point, and then with these arrows calling other functions, right? And you will find this in all the different dimensions, and this is very interesting because when you switch from one dimension to another, you will get a different representation and a different overview of your application, of this call graph. Because here it's CPU oriented, while there it will be memory oriented. And so it will be have a different representation. And this is really important when you're looking for issues, performance issues, or just bugs. It's important to switch from one dimension to another, because it will give you a full overview depending on what you're looking at. Of course, usually you start with the wall time because it's the more obvious, or to the memory, but really think about switching. And also, you may have noticed, even if I'm not zooming in, you may have noticed that there is a clear critical path that is being drawn by Blackfire. See, with these borders. So here with a green border in CPU time, but here it would be purple and pink in the wall time. So let's have a look at the I/O, for instance. We can see that, well, we have a path coming from top to bottom. And on the bottom, we have these two nodes, which are PO statements, that have a colored background, a solid background. And these nodes are where where PHP, or where we have the most intense things happening. So what does the border represent, and what does the background represent? It's all about inclusive and exclusive time. So this is important to understand this concept. What is inclusive? What is exclusive? See here in the function list, which is sorted by percentage exclusive, we have the different functions. If I click on like this one, so I have a summary of this very function with the different dimensions. So now, what is it all about with inclusive and exclusive? Well, let's have a look. Here we have as exclusive time 28.2 milliseconds, which represents 7.3% of the overall wall time. And inclusive time 63.4 milliseconds, which represents 16.6%. So what it is about? What is it about? Inclusive time is the time spent within this function and including all the subsequent calls. See these arrows there is the functions that are being called by this cast object function. This cast object function then calls the cast trace stub function. So this is the caller, this is the callee. So inclusive time will include all the callees, while exclusive time will only measure the time spent only within that function. So that's the difference. The inclusive time gives us the opportunity to draw this critical path, right? And when it gets lighter and lighter because, well, as we go deeper, we spend less and less time within the functions. And the exclusive time will be the time spent only in a very function. And this is where the background comes into place. So here we have this cast object. It has a dark background because it has a significant exclusive time. So it's worth your attention, basically. And Blackfire does this automatically for you. Just warning there. Here, a call graph doesn't have any time-based, right? It's only a matter of caller callee. It's only a relationship between one function to another. So this function with this one. This is the only guarantee that you have with a call graph. And that, of course, everything starts with an entry point, but that would be the only thing which would be time-based, because you always need a starting point. Okay, so now that we have this, let's browse everything. Okay, so we have this cast object. Okay, and we also have this create entity function. Okay, this is where we probably have our first bottleneck. And as this is all about doctrine ORM, well, I will say that I know nothing about doctrine, and I know nothing. I know I'm not Jon Snow, but anyway. So you may say to yourself, well, I don't care about doctrine. Doctrine is not my problem. My problem is my application where I have issues. And if this is doctrine, well, this is doctrine problem. I will say to the customer that we should switch from doctrine to something else. I don't know. Yeah, we could say that because this is vendor code. We could say the same if we would stumble upon a built-in PHP function. But let's think about it twice. Yes, this is all coming from the create entity function, which is being called 1,200 times, more of 1,200 times. So it means that we create ORM entities objects. We're creating 1,241 objects. Oh, that's a lot, right? And actually, I also can find this information here when I hover there. The database interaction, I have the number of SQL queries and how long they took. Same for the database connection, but also I can see that we have been using 262 ORM entities that have been instantiated. And here we only have 41, probably 20 have been lost here in the count for some reason that won't question it. I can also click here to view the SQL queries details. That can be very useful. Let's try to find out where everything comes from. So for this, I'm going to, from this function, from bottom to top, in order to find where in my application everything is starting. Okay, so here we have everything about still doctrine, a load to one-to-many collection. Okay, oh, here is where everything is starting. This app twig app extension gets user activity text. So remember, oh, Yeah, here we have the template that we were looking at in the timeline before. So within that template, something is calling this twig extension, which is calling get user, and another function in there, which is comment helper count recent comments for user, and everything is starting there. So we're called 23 times, and starting from there, woo, 21, 21, and boom, more than 1,000. So we probably have an issue there. So now that we have this clue, let's figure out what's happening, right? So I'm going to open my my IDE. Here I'm using PHP Storm. And it was citing show.html.twig. Okay. So it was using, it was about user activity text. So yeah, here it is. Okay, so let's try to figure out. Yeah, this is where we're looping over all the comments from the citing page. And, well, we're displaying the comment itself with the owner and the user activity text of the owner. Oh, do you remember? It's this. This. Okay, so it seems that this showing this label introduces some issues. So let's dive into the app extension itself. So this is here, app extension. This is a twig extension. Okay, so we're counting the number of comments that the user recently had. And based on this, we're returning a string, just a simple string. This is a very complex algorithm, isn't it? Right. And the count recent comments for user also appeared. It was stacked with the get user activity text, this one. Okay, let's have a look. It's taking the user. Oh, right. You might already found the issue. This is a very, very inefficient way to count comments from a user, right? Because here we're loading all the comments that the user ever made and instantiating the comments objects for it. And then we're looping over them and try to figure out which one is from the latest 3 months. We probably can do better, right? So probably the best thing would be to count directly from the database and extract the results directly from there. Okay, as I'm using Doctrine, I'm going to open the comment repository. Oh, right. I even have designed this function before, but I forgot to use it. Right. So here, count for user, passing the data immutable object, and creating the query with a count. This is exactly what we want. So instead of doing this silly stuff, let's fix it. So for this, I'm gonna inject the comment repository. So public function construct comment repository. Comment repository. All right, and I'll initialize properties. Okay. Now we have it, and I will do something much better. So like return this command repository, count for user, and passing the user, and the datetime immutable. -3 months. That should do the trick. Oop. All right. I'll have a look if everything is okay, that I did not break anything. Yeah, it seems that everything looks pretty good. Now, let's profile again. Yeah, look a bit quicker, right? Oh, you probably remember how long the wall time was in the previous profile. It was a bit less than 400 milliseconds, and now it's 243. So we could say, yay, that's a win. But, well, actually, before saying that it is actually a win, I like to know what kind of impact I had with my fix. Even though I'm pretty sure of what I did, always measure. You cannot improve what you cannot measure, remember? So for this, I'm going to compare the profiles. So for this, I'm going to jump into my Blackfire dashboard, where like all my profiles. So this was the first one. This is the new one. Yeah, 383 to 43. But I can actually compare them together. And yay, this is a win. Now we can see the difference and the impact we had. We had we dropped by 36% the wall time. We even dropped the IO time, the CPU time, and I can also click on this to have the representation here with a call graph. And I even dropped the SQL because it was the select comments was replaced by a count. And in the call graph, everything that is in blue is an improvement. Well, if we had something in red, which doesn't seem to be the case here, or maybe there, yeah, everything is in red would be a regression. But actually here, it's not that we have a regression, it's that we are replacing this function by this one. So that's okay. But sometimes it can appear that you need to choose between, you may have some trade-offs, basically. So, and it can happen between the CPU time, for instance, and the memory that you're using. So it might, you will be able to make decisions from like consuming a bit more memory to drop the CPU time or the overall wall time, right? It's your decision, but you have facts and figures that help you take this decision. You will not take this decision out of the blue and saying, yeah, this is where this is what I will do because I believe it is the right thing to do. You have objective stuff. You have facts and figures. And this is exactly what profiling is about, giving you facts and figures. Right. So let's get back to the profile dashboard and explore the latest profile. Because I didn't show everything from the interface here. So I showed you this, the SQL queries, the SQL part, and now we can see that we have only 44 ORM entities. It's still a bit high, but that remains reasonable. Let me show you a single trick. Like sometimes you want to know where my SQL query is coming from. I know that like this one is annoying me for some reason, because I don't understand what is going on, and I want to know exactly where it's been triggered by my application. So for this, I'm going to copy this one. You can see that it's also anonymized. I'm going to paste it in the search bar, in the function search bar, and voila. The list is being filtered, and then it's been filtered on where the actual SQL query was triggered. It's a PDO statement execute, right? And now you can see that it contributes SQL.pdo queries metric. But now I want to know exactly within the call graph. So for this, I'm going to click on this magnifying glass to center the call graph on this node. And here we go. Now I can browse the call graph from the problematic node, or so-called problematic node, and browse up to understand where it's where is the culprit. And here, well, of course, it's still in our comment repository and the comment count recent comments for user. But that was only an example. All right. I have also useful information there. If you hover the title with the PHP logo, you have lots of interesting info and metadata. So, well, of course, the URL itself, where your environment, your Blackfire environment, etc. Probe version, agent version, PHP version, etc. This is regular metadata stuff. But what is getting interesting is this cache information. You will have information all built in PHP caches. Opcache, of course, if it's not there, you should worry and activate it. I have 500 megabytes shared memory. That's quite big, but that's okay. I have this opcache intern string buffer. Well, what is this all about? Well, this one is actually very important because this is the buffer holding all the strings used in your application. And every time your application is calling functions that are using strings, the PHP engine will first look into this buffer. So in order to reuse, with the pointer mechanism, reuse the strings themselves instead of creating new strings. And as we're always using a lot of strings, this one is pretty important. So when it's getting full, you should consider increasing this buffer. This can be done in the PHP init. And other stuff like number of accelerated files, the PCU shared memory if you use it, the real path cache, the PCRE cache, etc. Just always keep an eye on those, because if they're here, it's because they can have a direct impact on the performance of your app, right? Something else that is quite important, quite interesting, is the recommendations tab. Woo! We have quite a few. Recommendations are built-in tests that are built-in within Blackfire web app that can be triggered based on the profile of your application. So here, for example, Blackfire detected that asserts.active is active, which should be disabled in production. Let's pretend that we are in production, right? Display errors that should be disabled, display startup errors, etc. And well, we can wonder why is that important? Well, for this, you can just click on the question mark, and you will get description and documentation about why this recommendation appears and how you can fix it. So this is all based on our expertise about PHP itself, on the different frameworks or contributions from other frameworks like Magento or Laravel or Celius or whatever in PHP, but also in Python if you're using Python Python application, like recommendations for Django, for instance. So if they're here, usually you probably want to fix it. Here it's a security one, and we have others like this one, which are performance one. Doctrine annotation should be cached. We should not have operation during a fast CGI finish request, or the PHP preloading should be configured. This one is interesting because we're using PHP 8. So we can use the preload mechanism that has been out in PHP since 7.4, and you can get quite a performance boost thanks to this. Especially if you're using Symfony, because Symfony has a built-in script that you can include include in the upcache preload. So it's basically the compile container and everything about auto-loading. So if you're using this script, Symfony won't have to boot up the compile container because it will be already in memory and preloaded by upcache. And same for most classes that are being auto-loaded by Composer, which can always be a problem because at some point you're always spending time auto-loading classes. Okay, so we have quite a few there. So, oh yeah, you should execute less SQL queries. Well, thanks, Sherlock. Yeah, 45 requests. Maybe we can do better. Symfony debug mode should be disabled. All right, this is because of this. This is quite an easy fix, isn't it? Okay, how can I do this? Okay, the constructor of the base kernel defines a second Boolean argument called debug. Oh yeah, of course. This is being done thanks to the .env file or exposed environment variables, the app.env environment. Okay, so let's try to fix all of this. So for this, I'm going to create PHP ini. So I'm using ddev here, so I'm going to add a new PHP directory. And by convention, it should be a my-php.ini. All right. And I'm going to copy paste my cheat sheet to fix most of these issues. Right. So I disable asserts.active. I disable display errors, startup errors. I dropped the max execution time, etc. And I also added the config preload.php. So config.preload, let's have a look at how it looks like. This is generated by Symfony. Well, okay, it's loading this one, the app kernel prod container preload. Let's have a look. Our cache. Oh, we should be in prod first. So, okay, let's comment this out for now. Okay, and I'm going to switch into prod. And as I change the PHP settings, I will need to restart my ddev. So ddev restart and ddev Blackfire to reactivate Blackfire. Okay. Okay, it looks done. Now, closing this. Yeah. Certificate. Okay, this I didn't break anything. I can see that I do not have the web toolbar anymore. Let's profile to check if everything is okay. That was 243 milliseconds at the first at the previous profile. Well, can you imagine? Just by fixing a few recommendations, this dropped a lot. Let's compare. Okay, I have a couple of red here, but yeah, mostly it's all dropped, especially in the CPU field. This is all about the var cloner. That's interesting. Okay. Let's have a look at the profile itself. See if we still have recommendations. I'm pretty sure we still have one. Now, Composer autoload. And, well, still having a lot of SQL queries there. Okay, have a look at recommendations. We have way less. Some issues with doctrine annotations. Composer autoload class map should be dumped in production. Okay, you probably know this trick with Composer autoloader. We should do Composer dump autoload with -- optimize at the very least. We can actually fix this quite easily. Well, I could run the command, but what I usually prefer is to fix this in the Composer JSON. And here the autoload, optimize autoloader, and set it to true. This way, fixing this in a Composer JSON, that would do the trick when you do any regular Composer install or Composer dump autoload directly. So without having to pass this optimize option or class map authoritative or whatever. Oh, I can even use the APCU autoloader. So that's even better. So instead of dumping a PHP file for the class map, it won't be dumped on the file system. It will be dumped in APCU memory. So that's even faster. So let's try this. Okay. So now I need to do gdev composer dump autoload. And as always, we're doing another profile to compare. Oh, we had a performance boost of 10 milliseconds. Well, I could compare again, but I think you got the idea now. And yeah, I had this. That was in my PHP. Let's now use the opcache.preload stuff. Oh, so here it must be an absolute path to the preload.php script. So in order to make sure of it, I'm going to SSH in my container. And yeah, okay, it's var www html. And yeah, okay, preload.php. So all good. But Now we need to be careful because as we add a preload script. Every time we're going to change something from the container or configuration or whatever in Symfony, we will need to restart FPM, PHP FPM, because the upcache preload and all upcache caches are shared to all the FPM workers. So if I don't restart FPM after each change, I won't see the change itself. Well, I won't see the optimization. So we need to think about that a bit. But you will see that it definitely worth it. Let's just do a ddev restart and reactivate ddev Blackfire. All right. Okay. Fine. Yeah, again, SSL issue because it's not on my local machine. Looks that I didn't break anything. Let's measure it. I was like 80 milliseconds, if I remember correctly. Let's profile again. Yeah, we gained 8 milliseconds, a bit more than 8 milliseconds more. So it's like 10% boosts. That's really important regarding what we had before. Remember, we had 400 milliseconds, and you knew nothing about this application. Let's pretend that I didn't either. The profiles gave me insights from within the application, and in order to spot where the issue was coming from and fix low-hanging fruit, or more or less, and then be able to address this kind of issues thanks to recommendations. We did not do a lot here, but the outcome is outstanding. I didn't want to show this. I wanted to go to the call graph in order to check the recommendations, but I think we're pretty good now. One thing that we could do, though, well, we still have time, would be to reduce the number of SQL queries. Okay, let's have a look at recommendations. Yeah, okay. Now we are using the .env configuration. Well, I should expose my environment variables instead. So I'm going to ignore it. And by the way, if you want to ignore it, you can create a blackfire.yaml file and just set this recommendations, that this one, the PHP Symfony avoid.env parsing, enabled false. Now we only have 2 real issues. One about doctrine annotations. It's about the entities metadata and the SQL queries. Well, I will ignore this for now, but in order to focus on this one. Well, it's true that 45 queries is quite high. So let's see how we can fix it. Yeah, it's all about the count, right? Maybe we can remove the count, at least for most people, for most queries. How can we do this? Let's think about it. Okay. Let's get back here. Well, everything is about this label, right? And this user probably have commented in other places on other settings on the website. So we will still have the calculation to get this label, even though we reduced drastically the time for and the CPU to calculate all this. We can probably do more. Maybe we can use caching, because well, this label will be needs to be bound to this user, and we can cache it like for 1 hour or something, because every time you will go to another article, another Bigfoot sighting, where this user has commented, this label won't have to be recalculated. And the same goes for this one and this one and this other user. So yeah, let's then refactor a bit and open the app extension again. I probably need to refactor this a bit. So get user activity text. Here, maybe I can, yeah, I will refactor this. So refactor, extract methods, and oh yeah, of course. Refactor, extract method, and calculate user activity text. And I will make it private and take the user as a parameter. Fine. Okay. Okay, I have everything. Now, well, what there are different ways to cache this, but I think here the best way would be to use a cache pool. So for this, I'll need the command helper, yes, but I'll also need the cache interface from Symfony. Symfony contracts cache. Yes, this one. Cache and initialize properties. Great. Oh, yeah, that could do here. Well, now that we have type properties, let's use them, right? Okay, get user activity text. Right. So I'm going to do some trick there and copy paste again to save some time. So the user activity calculation will remain as is. It should not be changed. Now we optimized it. We need to cache the result from the user activity text. So for this, me paste this. And here I need to import this one. Right, first I'm computing a key. Oh, the key must be bound, as we said before, to the user. So let's have a key like user activity text containing the user ID, right? So user activity text underscore 123. Then I'll try to get the result from the cache thanks to the key. So cache get, passing the key, and if we do not, we have this this item in the cache, then I'm passing this function, this anonymous function, using importing the user, make it expire after 1 hour, and returning the user activity text itself. Well, this is the most basic way of using a cache, the cache interface with Symfony, and I think that should be enough. Let's see if I did not break anything. Ah, okay, that works. And now let's profile again. Yeah, that was not exactly what I expected, but it still worked. Actually, at least it's not degrading. Let's profile again just to see. Okay, well, we're stuck at like more or less 75.6 millisecond, and we still have this. So maybe there's something that is not working. Oh, maybe it's because it's not. Oh. No, remember what I said? I got I got trapped by by the preload script. Remember what I said about the preload script? That now everything, each time you do you change something that involves the container, which is the case here, will not be available unless you restart your PHP FPM server. So, and it's exactly what I did. I changed something with the dependency injection container because I added this, and this service was already compiled. So yeah, of course we had the previous version. So now let's do some ddev restart and ddev Blackfire on. That should be better. I should sing a song when restarting ddev. Oh, maybe not. No, you do not want that. Yeah. Right. Okay. Well, it still works. Profile. Oh, that's faster. Yay! We gain like 25 milliseconds, something like that. So that's really a huge win there. And see that we dropped the number of SQL requests from 45 to 22. So clicking on it to actually see the profile. Yeah. Okay, we do not have any count anymore, and that's good because everything is in the cache. So yeah, I think we can be proud of it. We still, you can notice that we still have nodes with a dark background. It doesn't necessarily need that you need to fix something. It's just Blackfire saying, yeah, this in this node, in this function, this is where you have the most exclusive time. It doesn't mean that that's a problem, right? You'll always have a hot path, always, or more or less. You will always get these nodes representing the functions, and this is the case in every dimension. Even in memory, wow, we dropped. We have a very low memory consumption there. And in recommendations, oh well, come on, it's still saying that I should have less. I think I'm good, right? I don't know you, but I really think I'm good now. Maybe we can even more optimize, but better is enemy of the good. So you should know where and when to stop at some point. Oh, and I don't have either have this recommendation about doctrine annotations anymore. Yeah, so we did once done two birds. That's good. Cool. Yeah, so this is basically what the process of profiling when you can optimize a lot of things and very quickly. So here, of course, I know my application pretty well, but imagine applying this to your applications. Imagine this being automated, because this remember I said in the beginning in the slides that we also have this automation testing. Let me show you a bit of that. Yeah, directly on my dashboard. I show you a few ones. And we'll directly jump to Blackfire website, the Blackfire application, because yeah, we're monitoring and profiling Blackfire with Blackfire, drinking our own champagne. So yeah, it's about the builds. Okay, so about builds, we can have periodic ones, so that here every hour Blackfire is running a scenario, which is being defined in Blackfire .yml for Blackfire application. And what is it all about? We have different scenarios. Each scenario is composed of different steps, and each step is being profiled. So for this validator scenario, I just visit this blackfire.io/validator. Here I'm submitting a blackfire.yml file on the same page, etc., etc. And for each scenario, I will have a profile. So, and this profile will be evaluated against different constraints that have been also defined in the .blackfire.yml file. So let's have a look at this one. Yeah. So yeah, the main wall time. Well, this one is a bit complicated to explain. Let's have this one. Pages should not have too many SQL queries. So in my test, I say, yeah, I want for this page to have less than 15 SQL queries. They should be light as well. So we do not want to exceed 220 kilobytes. Should not tag a graph. Yeah, okay. This is a specific metric, and we do not want to have too many Elasticsearch queries. So, and these builds can be run either periodically, like here, they're configured to run every hour, but also using a deploy hook. Like, we're part of Platform.sh, and if you use the Platform.sh webhook, the integration with Blackfire, each time you deploy on a new environment, Blackfire can run your scenarios. So that's very useful if you want to validate your pull request, because for each pull request, Blackfire is able to, not Blackfire, Platform.sh, sorry, is able to spin up a new environment so that you can test it. And once it's pinned up, Platform.sh will trigger Blackfire to check all your critical scenario. That's very useful, because it can give you a status of a pull request. For instance, if your performance tests do not pass, you know that on your pull request on GitHub can be blocked. Or if you did a deploy in production and that you have issues with your automated performance test, you may roll back. Right, so it can help you give a decision. Thanks to this notification channels, by default, you have an email report. You can also have a Slack notification, but also notifying GitHub, GitLab, Bitbucket, or just a regular webhook, etc. And triggers can be builds can also be triggered by a webhook, like. Imagine you're using a third-party monitoring system, for instance. Well, I would be very sad, but that's life. If you're using New Relic, for instance, you can tell New Relic, well, as soon as you have you cross this threshold in your alerting system, please run a periodic build. Not a periodic, please run a build, basically. So how can we do this? I'll quickly show you that. Yeah, I have some time before wrapping this up and answering to your questions. So yeah, test. Writing test. So writing test is something like that within a Blackfire.yml file. In this Blackfire.yml file, you can find test, metrics, and scenarios. So here's a very simple one. based on the main wall time. So the main, when you have main in front of the metric, is the main values that you have on top of each profile, like here. This is main.wall time, main.io, etc. So it's basically like a unit test, except that you won't have to program it. Everything is declarative here. You give each test a name, a context, and a collection of assertions. And if one of those assertions fail, then your test fail and your build fail. And if all your tests pass, your build is passing. Yay! So you can have different contexts. Well, mainly two. HTTP context. So in that case, you will have a path here with one or several regular expressions based on a URI. You may even filter with exclusions and HTTP methods. You can also do this with commands like this. And then it would be regular expressions based on the CLI command itself. And the assertions here, well, based on metrics, we have a lot of built-in metrics that you can find in the metrics documentation, or main ones. You can also define your own metrics. Well, the metrics documentation is quite extensive. And please keep in mind that this is a very powerful feature, that you can define your own matrix, because it will help you define tests on your business logic, not only on generic metrics that we provide, but also on your built-in, on your business logic. And it will even give you the opportunity to modify how the call graph is rendered when you capture arguments, for instance. You can get conditions. This, and with conditions, this one is pretty interesting. A database connection should be open only when queries are made. Yeah, of course, if you open a database connection, this is for something, right? If you do not open a connection, if you do open a connection and do not trigger any SQL query, this is a waste of time. This is a waste of resource. So this is what this test is about. For all pages, when metrics.sql.connections.count strictly superior to 0, then I must have at least one query. So metrics.sql.queries.count strictly superior to 0. If not, well, you know that we have a waste of resources. Okay, this is all about the tests. But after that, all these tests will be evaluated on each time you do a profile, even if it's not automated. So I can show you this actually. So let's switch to the. Oh, right. I need to restore everything. Git restore. And composer and src. Yeah, and src. And then git switch. Oh. Git restore.ddev php my php. Sorry, guys. Right, now we have everything fixed for this workshop, and let me show you this .blackfire.yaml file. So here is the metrics part. So you can see that I define custom metrics. Remember, this is what we fixed in the beginning. Actually, now this metric says that I want to trace every call to this function, and every call to this function will be part to this metric. Same for another one, and agree to terms. That this is also another issue that can be has been fixed with my my finished branch. And here are the tests that I defined. That my homepage should be fast, the number of created entities should be reasonable. So this all this is based on built-in metrics. Same for the autoloader class map, and my user activity calculation should be cached. This is the last fix we did before the recommendations. And this has as a context all the citing pages. And here is the assertions. I'm using my own metric to test it. So this metrics that app user activity calculation count equals to 0. Why? Well, because if I have called this one, it means that this function call is not cached. So that should fail in that case. And here, what a scenario would look like. So a scenario can be run with with Blackfire builds that I showed a bit before, and can be also run with the open source Blackfire player. So Blackfire player is HTTP client, which main capability is to read scenarios like this. So you can define scenarios and automate HTTP request. Just keep in mind that it doesn't evaluate JavaScript yet. At some point it will be possible, but for now it's not. It's a simple HTTP client. And it also has an integration with Blackfire profiler to trigger builds. So when you run Blackfire player, you pass the appropriate option, so the appropriate Blackfire environment name. Then it will run your scenario and profile every step within your scenarios. So I have very few. Actually, I have only 2 scenarios. A very basic one where I visit the URL and I do some expectations. So these are assertions, but not based on profiles. These are functional assertions, basically. So we use a different verb here, not to confuse assertions based on the performance test and assertions based on the functional test. So status code should be 200, and that I should have 10 elements based on this CSS selector. Then I click on a link. So here I base myself on the third link. So I want to click on the third link in the list based on the CSS selector and do some expectations. And here, this request will be profiled. This request will be profiled within the same scenario. So same scenario, meaning the same session, HTTP session. So that makes it possible to do some authenticated visits like this. So here I'm visiting the homepage and I'm logging in. I'm authenticating, right? Well, here the param are being hard coded, but you can set some variables and inject some variables. Well, I won't get into details about that. And then I follow the redirection and check that I'm correctly logged in. And the good thing here is that once I'm authenticated, I'm staying authenticated as long as I stay in the same scenario, because all the steps within a scenario will share the same HTTP session. So the same cookies, the same HTTP oath, if a basic oath, if applicable, if you define this. And then if you automate this either with Blackfire builds or deploy hooks, or even in your CI system, you will start to get really automated tests, performance test with synthetic traffic, because it's not real end user traffic, so it won't impact, the profiles won't impact your users. So that can be very useful, especially when you trigger a deploy, when you trigger a webhook under the pressure of traffic, etc. the next step after this would be to activate monitoring. And the monitoring here, like showing a bit like how it is. So this is the load, the monitoring of Blackfire.io. So we have quite some traffic. This is like between 4,000 and between 4,000 and 8,000 requests per minute. So this is timeline selection. I can expand it. So here, this is an event that occurred. And this event appears here. And it's a deployment. So that we can check what happened, what is the results of a new deploy. Did it improve? Did it the performance load, or did it degrade it? Well, this is usually something that you want to know when you deploy something. These are filters on HTTP status and response time distribution. And we also have this response time breakdown. So this is services monitoring. So here is the blue part is the time spent within the application, but the smaller parts are coming from AMQP requests or external HTTP requests or Redis or SQL queries. So that can give you an insight of what's going on, especially not in your PHP app. So thanks to this, you will be able to see if some of your SQL queries are being problematic. And remember, I talked about the when and the where. Here is all about the when, and the where is coming from this, the top transactions. A transaction is an identified request. So each request here is corresponds to a controller action. Well, because Blackfire.io is a Symfony application. And here everything is sorted by impact. It means impact for your end users, where most of your end user requests come in, right? So that will help you make a decision on which to fix first. Well, here, if you have an important response time, like here on push to profile action, you may wonder, is it worth fixing it in the first place, maybe before this one? This one has more impact than this one. Well, you can make those decisions. And then focusing on a transaction gives you the same overview, but this time focused on your on the transaction you selected. So same response time breakdown, the top services that are being used, MQP and SQL here. You can have spans. This is like a micro timeline on what's going on within your application. This is all about extended traces that I explained in the very beginning. This data has been extracted in 1% of all traces. And they give us a deeper insight than traces. So yeah, here it's all about the service container and HTTP client factory about Sentry, etc., etc. So with this, you will start to have a bit of information on what's going on with your app. You have the recommendations, of course, and this is where it's getting very interesting. Monitoring has also the ability to trigger automatic profiling. By default, Blackfire will take the top 10 transactions, the most impactful transaction every day, every 24 hours, and trigger profiles for these transactions so that you can have a real overview on real traffic. So because this automatic profiling will be on real end user traffic this time, but very selected ones, only one request, which will be played profile automatically. You can also program on, like here, if I click on profile next request, let's do this. At some point it will appear. So that one was made 10 hours ago. If I refresh, at some point I will have mine. Yes, here it is. So less than a minute ago, this is the one I configured. So now everything is, coupled, but intelligently coupled. You can use monitoring together with profiling and testing, because in the health report here, you'll have also a build and test part, and saying most impactful untested transactions. So all of your transactions that are important for your users, if you have some that are not automatically tested with performance with builds, they will appear here, and Blackfire is inviting you to test them. All right, I think I did quite a tour on what Blackfire can help you with, especially with profiling. I finished with monitoring, of course, but made the most focus part on profiling, what it can help you with. And well, now is time if you have any question, any comments. Well, we have like a bit less than 15 minutes to get through them. Thanks for your attention.
Hey, Jérôme, thank you very much for your presentation. It was very, very insightful, and we have quite a couple of comments and questions. So I would start that we make the best out of the time and jump right into it. So Let me see, where do we start? A simple one. Jörg is asking if there is a limit on the requests.
The limit on the requests?
I would say maybe he's talking about like how many profiles or so you can make. Is there some limitation or something?
There is a limit, but this is like any API limit, just that you do not want to abuse some kind of API. The basic limit is 1,000 profiles per day. So this is usually more than enough to cover your needs.
Okay. Jörg, I hope this answers your question. If not, please resubmit another one. Then let me see what makes sense. Grubor is saying, as we were talking anyways about monitoring, but Grubor is saying, I'm looking into New Relic for observability, I think he meant to write. Seems that there are several feature overlaps. What are the differences?
Well, this is a good question, because we have often this one asked. New Relic is a monitoring tool, mainly. So just like Blackfire monitoring, it's not a profiler. It will at most give you what we can have with extended traces, so a deeper insight than regular traces, but you won't be able to deep dive into an application behavior like we did during the workshop. This is not a profiler. And the difference is with Blackfire monitoring, well, New Relic has a lot of features, and we don't have all of these features. So there is no pretension to be a 1-1 replacement, but it would be it would cover most of it, like regular traces with only one component, which is the Blackfire component, the Blackfire probe. What I showed, for example, with the services monitoring, where you could see HTTP request on the monitoring part, SQL requests, Redis, and IMQP, etc. This doesn't require any additional agent. like you would need for New Relic. And also, New Relic supports several frameworks, and only those frameworks will support any PHP application. And last but not least, New Relic dropped support of PHP ZTS, Z Thread Safe, which we still support and will continue supporting.
Okay. I mean, as it's a bit of complementary, is it possible to use both services together?
Yeah, for sure, and that's what I explained. You can definitely use New Relic for monitoring and Blackfire for profiling and automatic testing. And I also mentioned for automated testing, performance testing, you can we have an integration with New Relic. With their alerting system, you can set up an alert, and when the alert is triggered, configure a webhook to trigger the builds, the Blackfire builds, so that you can have real profiles when you're in the pressure of traffic.
Okay, thank you. Then, as you mentioned, anyways, compatibility. Jules, I hope I pronounce it right, is asking, we have a legacy application which uses PHP 5.3 and also some parts run on deprecated versions. How about the support there?
Well, we still support PHP until 5.3. It's not. It won't be. From. We support PHP from 5.3 to the latest versions, and we will even have the 8.1 probe ready when it's been released. It's just that the PHP 5 ones, the probe for PHP 5, won't receive any updates except for security, etc. But it will still work to be profiled, and that's about legacy application. It's always good to have to do some profile, because it will help you understand how it works. Of course, you will be able to identify bottlenecks, but it will really help you understand how it works.
Okay, perfect. Let me see. Also, for the folks asking, like, if who joined maybe a bit later, no problem. You can watch everything on demand later as well. And I'm also sure that Jérôme will be happy to answer some questions also after the event.
Sure.
Maybe again, if you could repeat, like, what's the best way to contact you or your colleagues?
To contact me, you can contact me on Twitter. I don't know if it's advertised somewhere, or support@blackfire.io. I'm usually behind it with two of my colleagues answering questions directly on support.
Okay, cool. Then Sergio is asking, can Blackfire be also used to monitor endpoints APIs?
Yeah, of course, yes.
Good, short and sweet answer. Then Leary is asking, can you show the config file and briefly explain it? I was late on the workshop.
Yeah.
Put on the screen sharing again.
Okay, let me share my screen again then. So I guess you were mentioning the .blackfire.yaml file. So this file holds different parts. First, the metrics, tests, and scenarios. Metrics is the metrics section is where you will be able to define custom metrics, because we have a lot of built-in metrics, but most of them cover frameworks and CMSs, etc. But if you want to cover your own business logic and to be able to run tests against your own business logic, you will probably need to define some metrics. You can name them whatever, however you want, and they are based on matching PHP calls. So I suggest you get to the metrics documentation page for extensive explanation. But basically, you have a matching call here in PHP. with the callee. So the callee again is the function that's being called. So each time this function is called, so count recent comments for user from app service command helper class. Here it's preceded with a prefix, which is a selector. I won't get into details, so you should have a look at the documentation for more information about this. You can also filter by color. So I want this function to trigger to increment this metric, but only if it's being called by this other function. So this is a way to narrow down the selection. So this is mainly about metrics. You can have this timeline if you want it to appear in the timeline view, set a marker in the timeline, etc. Then the test part is where you set all your performance tests. So any test is composed of a name, a context, so here a path. It's always a regular expression based on the URI if you're in HTTP mode, and a collection of assertions. That can be one, like most of them here, but you can add many. And all the assertions are always based on metrics. So let's take this example. So user activity calculation should be cached. So this one is based on the metric I defined earlier. So here, app.user activity calculation. Just note that I prefix it by the metrics keyword followed by a dot, and it's also suffixed by the dimension I want to test against. So here it's the count, so the number of times this has been metric has been incremented. So basically the number of times the function has been called. And by the way, this is usually a good practice to do so, not to rely on time, because I could also say use wall time here instead of count or IO, and use some absolute time values. But this is usually not a good idea because time is a volatile measure. So, and it's always a consequence of something, and usually it's a consequence of having functions being called. So you need to identify the functions and then base your test on the count here. So here I have like maybe a dozen. And the scenario part is what I explained in the end, where this is the part used by Blackfire player, whether if you want to use it to run it directly from your CI system, for instance, or for your local machine, or from Blackfire builds system periodically. So you can configure your website to run this to Blackfire to run these scenarios on your website, and it will do this like every hour. And then I hope this clarifies.
Okay, thank you. Thanks. Then we have one question from Speedy Gonzalez, which I'm very sure that this is not the real name of the person, but yeah, okay. Speedy Gonzalez is asking, how would you go around Cloudflare CDN? Is that doable?
Sorry, can you repeat?
How would you go around, maybe it's meant bypass or so, Cloudflare CDN?
Oh, it's
or anything like that. I think it's not just Cloudflare.
Yeah, that's a good question. Yeah, Blackfire profile triggering is based on a header, HTTP header, which is X Blackfire query. This is well documented in Blackfire documentation. So basically, you need to configure your CDN like Cloudflare, CloudFront, or even Fastly, Varnish, whatever, to pass through a request that contains this specific header. That's how it is done.
It's quite simple, actually, right?
Yeah.
Good, perfect. Then let me see. There is a thank you. Thanks for the session. Thank you. At the very beginning, there was a question about the if Blackfire only works for PHP, but I think you mentioned it's also working with Python. I saw also Go on the website. So
Yeah.
Anything else?
So Python and Go are already usable. Python is especially is quite mature. We're working on a Ruby one as well that will come out at some point, but still need some maturation. And the one for Node.js is planned. I don't have any date to give you, but this is in the works.
Okay, so I think this was already the last question, if I didn't oversee anything. Jérôme, is there anything else you want to share with the community for the end of the session?
Well, I want to say to all of you, happy performance optimization. Now you know that it's important to wear these bionic glasses, right? To understand how your application is behaving, and always differentiate the code of your application and the application itself, because they're not the same thing. And it's important if you want to improve or understand how an app works.
Yeah, perfect. And I would say it's not that hard, as we saw in this 2-hour workshop. Time is flying, and we also saw a lot of code on stage or in the presentation, which is really, really cool and always a good sign. So Jérôme, I want to say a big thank you for joining us today, and hope to see you soon again.
Yeah, thank you. Thank you all. See you soon.
Thank you. Bye, Jérôme.
Bye.
So I hope you have enjoyed the workshop. It was quite interesting about a very important topic, because performance is always a topic for us developers. With that said, we are already a bit short on time, so we are going into a 1-hour break, and we'll come back at sharply 1 p.m. Central European summertime with our afternoon talks or noon talks. So we will talk about GitOps, we will talk about serverless, we will talk a lot about DevOps in general, and we will also get insights into how Netflix uses DevOps. So with that said, have a nice lunchtime, grab a coffee, and see you in all freshness in 1 hour again. Bye-bye.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.